Okay, so it's really great to have Rachel here from Columbia University. She's going to be telling us about some exciting new work. I think we're one of the first audiences to hear about this.
Thank you, everyone, first of all, for the invitation and your time, and also for kind of allowing me to present something new and non-standard that's not like what I typically do in the DP space. And so this is some like very fresh work. We're try and kind of like understand how should we explain differential privacy to lay users to enable them to, first of all, have the correct perceptions of what privacy guarantees they're getting, and then also be able to make like, informed choices based on that. So I will start off by saying this is joint work with two like fantastic people, Gabe Kapchuk, who is at BU, and he's a cryptographer who likes thinking about like tech policy, but he's really in the like security space. And Alyssa Red Miles is at Microsoft and at Max Planck, and she works on like usable security, HCI, survey design. And then you have me, and I work on like algorithm design in this space of like DP, and our joint interests all brought us together to this question: how do like non-experts think about DP? So I'm guessing for this audience, I don't have to like explain DP very much, but in like typical talks, if you want to explain DP to a privacy audience, you typically include some version of my next two slides, where you have a picture and you say like in pictures, differential privacy ensures that if I plug some like particular database into my favorite randomized algorithm, that's going to give me out the PDF curve of the outputs of this algorithm instantiated on this particular database. And if I were to change one person's data, say I changed Chris into a Javier, and I plug this same database that is different in just one person's data into my same algorithm, I'm going to get out a slightly different PDF of the possible outputs. And in the privacy guarantee ensured by like a differential privacy tells us this ratio is going to be bounded like a pointwise everywhere in the domain. In math, it says this. We'll say that an algorithm M that maps from a data set of size n into some arbitrary output range R is going to be parameterized epsilon differentially private if it is a case that for all neighboring databases D and D prime that are the same except for one person's data, and for all possible things I may produce as a result of this analysis, I'm going to produce that thing with about the same probability under these two neighboring databases. And this like about the same is captured by this parameter e to the epsilon, and the epsilon gives us a privacy parameter. We may also have a kind of like additional like a delta term here, and that gives a kind of like additive delta slack term here, which enables like a probability 0 events on the right-hand side. And then like presenting differential privacy to other like computer scientists, we talk about why is this technical definition capturing the right things we want of our privacy guarantee. We can say that it bounds how much one person's data affects the result of a computation. We can guarantee that we're bounding the probability of all like bad outcomes that may happen as a result of analysis on your data, whether that's your like health insurance prices rising, or whether it's like stalkers coming to your house. I'm going to say that thing would happen with about the same probability whether I saw your data or if I didn't, or if kind of like you were truthful or if you lied. And so I'm saying these bad things are going to happen roughly like independently of your data. And this is addressed in the like privacy textbook that we all know and love. They write, quote, DP addresses the paradox of learning nothing about an individual while still learning useful information about a population. And so we're telling people we're learning aggregate things, but we're not learning about you. And if I learn about you, it's because you belong to a population that I have learned about, and that's the goal of doing machine learning. And so this is fine for an audience like this. But it's less fine as we deploy these things in practice as we're doing. And in fact, thank you to kind of everyone on this call and on the team for being a part of pushing a differential privacy into practice. Fantastic. And the question is now, how should these organizations, including Google, and also including other future groups who may want to use DP in the future, explain differential privacy to their users? And they should probably not give them a mathematical lecture talking about bounding Bayesian inference based on your data. We should probably give them something concise and quick. And you see things like this. What happens on your iPhone stays on your iPhone. And I'll say, I know that I'm at Google, and I specifically chose an ad that was a different company, so that kind of no one felt attacked personally. But we see things like this. How you have to translate pages of math, slides of technical conditions onto a billboard. And you don't want to put the definition of a DP on a billboard. You want to put a cute saying. And we would like to understand, what should we put on our billboards to make sure people really understand things? And I want to kind of acknowledge, before I go into our work, I want to acknowledge this is certainly only one piece of the puzzle. And so we need DP explanations for engineers. And if this is a place where truly Google excels at this, you guys are doing fantastic, and you have all these repos, and you have all these articles, and you have all these papers, and you're incredibly transparent. And I want to give so much credit for that, because you guys are really advancing the state of DP in the wild. And as an academic who has never done anything useful in my life, I'm very happy people are actually doing important things. In this talk, we're going to be focusing on how to explain to a lay user. And so while this may be very transparent for other engineers, it's not at all transparent for someone's Midwestern grandma who doesn't have a smartphone but wants to care about privacy. And so this is going to be the focus of this talk. And I want to also acknowledge lawyers, policymakers, regulators are important. I actually have no idea what they care about. I guess they care about Harvard Law Review, but I truly have no idea. But I want to kind of before I jump into this talk, I want to acknowledge there's certainly a bigger picture happening here, and we're focusing just on this part, on people who we assume don't really know math, but they still care about their privacy. I want to pause. Any questions on kind of the goals and scope before I tell you about the actual work?
I have a question, Rachel.
Sure, yeah.
In 2017, when we did the DP work at Apple, there was a survey done by 9 to 5 Mac on general population. How much are you comfortable sharing your data via DP? I think the population was 1 million or something. 50 to 70% of it said that I'm very comfortable sharing my data with DP. Now, clearly, I cannot expect 70,000 people in the planet actually understands what DP is.
Yeah,
the question is, how do you handle that kind of a situation?
Yeah. Fantastic. I'd be very curious to see that survey. I don't know if it's public or if it's internal Apple things.
I just shared it.
Yeah. Okay. Yeah. That'd be fantastic. And we actually do something very similar in this work, as you'll see. Only we ask, when you tell people we're going to use differential privacy, what else do you need to tell them about differential privacy for them to be able to make informed decisions then? But I would love to see that survey. Yeah.
So basically, the high-level question was how does this whole line of work relate to brand advertising? User trust the brand more than the technology itself. So how does it fit? That was the question.
Yes. Yeah, exactly. Is we all understand, at least in this call, precisely what a differential privacy does and doesn't do. And the question is, for people who do not have a rich understanding, and it's unreasonable to expect them to have a rich understanding, we should still give them some information. And the question is what should we tell them? Yeah. And so in fact, our model of this is going to be, imagine that we have some kind of median user who is informed and cares about privacy, but is certainly not a differential privacy expert. And I'll say that when Gabe gives this talk, he uses like, himself, and he's like, I do crypto, I do security, and I like, appreciate privacy is important, but I like don't super understand the nuances of what DP does and doesn't do. But I feel uncomfortable having a slide making fun of Gabe for not knowing DP, and I also don't think it's fair if I have myself on the slide. So, and there's a cartoon person who thinks about these things, and they're gonna like interact with a good company. And so in this model, we're taking away questions of concerns. Is this company ethical? Do we trust them? Are they doing the right thing? And we're going to say in our story, yes, and they truly are good. And the question is like, how do they convince users they are good? And they're going to say, have my product, it's great. And the user will say, I want to and I love your product, but I'm also a conscious and savvy consumer, and I'm concerned about your product's impact on my privacy. And the good company might respond, don't worry, we are good, we are ethical, it's fine. And this user might say like, no, actually, like, I really do care, I want to be informed, tell me what you are doing to protect my privacy. And the company might respond, in that case, we're going to use DP, epsilon equals 10. And the user will say, what? As would probably happen if you did this to a kind of like average case user without any more information. And so we're going to kind of like, delve into this question. We are using differential privacy is probably not where the explanation should stop, but rather we should probably be giving much more information in terms of the type of privacy guarantees that are provided by this tool. And in particular, we're going to ask 4 separate research questions in this work, and they're going to be grouped into the first 2 and the last 2. And the first 2 just ask, what do users care about in terms of privacy in general? And so this asks, how should we address the information that we provide about our DP algorithms? And so, for example, do users care about the type of protections provided by DP? And then also, if they have increased confidence against those information disclosures, does that increase willingness to share data? And so these are more about kind of general, what do users want, privacy and security. And the next 2 are about specifically, how should we describe differential privacy as we present it to them? And does a description impact users' expectations of protections against these information disclosures? And also, how does that impact willingness to share data? And we're going to, in this talk, spend kind of a little bit of time on these 2, and we're going to spend more time on these 2 because these are much more core to the kind of DP question. And the research plan, how we achieve this, and it's also an outline of the talk, is we performed a series of a vignette-based surveys to kind of elicit people's privacy preferences and their privacy expectations. This was performed on Mechanical Turk from users who were American, and we had 2,424 people across all these different surveys. And to address our first 2 questions, we would present users with a specific information sharing scenario, and we'd ask them, what are you concerned about for your privacy in this example? And we then tell them their privacy expectations they can have in terms of those concerns, and we'll then ask them, given these privacy expectations, would you share data? And this allows us to kind of measure what are the privacy concerns users have, and then how well do those align with the protections actually provided by a differential privacy. And then to address our next 2 research questions, we first performed a kind of data collection adventure, how we collected descriptions of DP in the wild, and we then returned to our same information sharing scenarios, and we gave users one of these DP descriptions, and we then asked them, what do you expect in terms of your privacy, and also, would you share data? And this allows us to measure how accurately and effectively DP descriptions are going to set users' expectations in the wild using the current state-of-the-art DP descriptions being used. And again, this is an outline of the talk. Any questions on this before I jump into the like, you know, surveys and things? Okay. And I'll say in general, here's a kind of pipeline we were trying to like capture, is we understand the way DP is like described in a billboard type of sense will certainly impact users' privacy expectations. Those privacy expectations will certainly impact, are they willing to share data? And so our two surveys address these two things. Here's our first survey, and like here's our second one. And we're trying to kind of understand how these like DP descriptions filter through this process at the end to kind of impact willingness to share. And our kind of like ideal DP description would both give users correct expectations of the privacy guarantees they're getting, and also like, you know, induce them to share data because they understand they're getting privacy guarantees that are strong. We have to kind of understand how do these processes work inside the mind of the user, which is a mysterious place. Okay, and so our first vignette said this. It asked about people's salary data. And we told the users, imagine that you work in the banking industry. You are friends with a group of other people who work in banking companies in your city. One of your friends is a part of a transparency initiative that is trying to publish general statistics about pay in the banking industry. As a part of this initiative, they have asked everyone in the group to share their salaries and job titles using an online web form on the initiative's website. And we also had a second vignette asking about medical data because we understand users' privacy requirements may depend on the context of their data. And so in this one, we told them, imagine that during your next doctor's visit, your primary care doctor informs you that they are part of a nonprofit organization trying to push the boundaries of medical research. This nonprofit is asking patients around the country to share their medical records, which will be used to help medical research on improving treatment options and patient care. Your doctor, with your permission, can facilitate the nonprofit getting the information they need. And so those are the two stories that we gave them. And then we asked them about their privacy concerns, about 6 possible information disclosure possibilities. And we named them, for short, these things on the left, and we told them, here is what I mean by this. And the first one is asking about hacks. And so this expectation says a criminal or foreign government that hacks the organization can learn my data. Law enforcement says law enforcement can access my data with a court order. Organization is about the kind of organization collecting data, and this one was different across the two vignettes. In the first one, for salary transparency, we asked, my friend will learn my data, because this is your friend who is collecting your data. And in the healthcare example, we said my data will be stored by the nonprofit as opposed to being stored only by your doctor. Number 4 is about a data analyst working for the organization, whether they can learn users' data. The fifth one is about graphs or other informational charts created using the collected information, being able to reveal users' data. And then finally, we talked about sharing data. Data that the organization shares with kind of other organizations could reveal my data. And so this is kind of third-party sharing. And so these are the 6 things that we asked them about. And our survey went like this. And so our first question is we gave them randomly one of these 2 possible vignettes, and then we asked them, which of these information disclosures of these 6 would you want to better understand before sharing your data? And for the ones that they chose, of those 6, we would randomly assign them one of the following. We might say there is no risk of this information disclosure. And then the next 2 are high risk and low risk ones. And so this is the risk of this information disclosure either being like the same as or being higher than the chance that your bank account will be compromised as a part of a data breach in the next year. And we specifically chose these high risk and low risk conditions to be anchored to a specific event, because there has been a lot of empirical research showing people are remarkably bad at reasoning about probabilities. And to them, a 1% chance is the same as a 0.01% chance. And so if you just give them numbers, people typically cannot reason about these. But if you anchor it to a specific event, they can at least reason about that. And it's important as we move into later in the talk, talking about accuracy of expectations and whether their expectations match the ground truth of privacy. It's important to kind of acknowledge we're not talking about an epsilon here. And so of course, the ground truth, which of these is true, will depend on the choice of epsilon, and we are kind of not going to address that. And we very much point to it as a problem for the future. Anyways, and so we have our kind of no risk, low risk, high risk conditions. And then we ask, after we have told them these are the risks, then we ask them, would you be willing to share your data with this initiative? And our first question is just asking which information disclosures do they care about? And we found they cared about pretty much all of them. They cared a whole lot about third-party sharing. They cared a whole lot about having the organizations see their data, also hackers. We were actually surprised that we saw a difference between the kind of organization and the analyst, because we think the analyst is an employee of the organization, and how do you draw the boundary between the analyst and the organization? And we as a research team actually thought that was a kind of redundant question. And so in this case, we were pretty surprised to see they had quite different answers. And there was a free text response, and some people said this is because the analyst has to see my data to kind of learn things about it, and the organization is unclear who's going to see it. Is it the CEO? Is it the janitor? Is it just laying around somewhere? And so to them, the necessity of access to information actually did play a role. To address our next question, asking how does the probability of these information disclosures affect sharing? Here's a plot of our results, and I will say all of these things came out of a logistic regression model conditioned on the respondents who cared about the a specific disclosure. And so we have these disclosures and the columns, and we have these comparisons, no risk, low risk on the rows. And we quantify willingness to share data according to this odds ratio. And so this measures a change in odds of sharing data compared against a high risk condition. And so having an odds ratio above 1 means you're going to have increased sharing compared to the high risk condition. And we also provide confidence intervals at the 95% level. And so some things to observe here is we see certainly having a lower risk of hacking will certainly make users more willing to share data. And so in fact, if there's a low risk, users are about twice as likely to share data compared to a high risk. And if there's no risk at all, then they're about 3 times as likely to share data. But we also saw that having kind of a no risk or low risk of sharing data with the organization made them more likely to share data, roughly time and a half more. And we interestingly don't really see a difference between these low risk and no risk conditions. And so this says people are kind of fine having a low risk, and they're about as likely to share if there's kind of no risk or low risk. On the other hand, as we look at kind of a law enforcement and a third party sharing, it turns out there having only low risk of this event is not sufficient to increase sharing. And it really makes a difference only if you are in this like a no risk condition. And so that's like an interesting thing to observe. Also interesting, analysts and graphs didn't really change willingness to like share data. And this is like a particularly interesting because we know on this call that like a protection against graphs and other like, statistics computed on the data is a one thing that like a differential privacy definitely guarantees. And these other ones depend on the like, implementation, and in particular local versus like central privacy. Any questions about this before I move on to the like DP descriptions part? Okay. And so now let's revisit this kind of like hypothetical conversation between a company and a user telling users it's okay because we use DP. And so in practice, companies don't just say, in that case, we use DP, but rather they have to give one more sentence saying, and differential privacy is blah. And so we like went out in practice and we found how are these things like described in practice by the groups who are deploying DP, by journalists, and by academics. And we saw some themes arising. For example, we saw people talking about how like a differential privacy is a kind of like a gold standard in privacy protection. And that's fantastic. I feel very comfortable if a person tells me this, but I also have no idea what it's giving me. And then we saw some sources describing like precisely what is differential privacy doing. And of course, it wasn't at the notion that we are used to thinking about of like, carefully calibrated noise, but it does talk about like, scrambling individual data, links getting blurred between data points and their sources. And so this is more about like, how is it achieved? And we also saw some groups talking about what it enables, right? And so it enables us to learn things and it won't change the core findings, or it allows general statistical analysis. And so this is kind of focusing on the positive. If we have DP, we can still do these things. And then we saw some that were talking more specifically about risk and talking about the risks that are mitigated by using like DP. And so we like took these and we gathered a whole bunch of things across industry and across the press and some academic papers. I know exactly what's a like academic logo. We don't really have one. And for these, we included only differential privacy papers that had at least 500 citations to ensure that we're really focusing on the papers that are core in the DP community, not a kind of like one-off that may not capture really how is DP actually described by the research community. And so we found 6 themes that arose. And from those themes, we would kind of like put these like DP descriptions into themes. And then like in each theme, we created one synthetic DP description that kind of captured the kind of like, essence across multiple like descriptions in the group. The first 5 of these do not correspond to any one existing definition, and the 6th one does, but rather they were done to kind of like, capture like a content across this group. And our first one is one that we're calling no substance. And these are things that kind of talk about how great differential privacy is without telling you anything meaningful. And so like specifically we say that like differential privacy is a gold standard in like data privacy and protection and is widely recognized as the strongest guarantee of privacy available. And so this is very convincing, but also like non-informative whatsoever. And the next one focused on the techniques used to achieve differential privacy. And so for this one, we wrote, differential privacy injects statistical noise into collected data in a way that protects privacy without significantly changing conclusions. And our third one focused on what differential privacy enables. And so for this one, we wrote, differential privacy allows analysts to learn useful information from large amounts of data without compromising any individual's privacy. And our fourth one is an appeal to authority. And we found two different types of authority. One of them is an appeal to kind of math. And they talked about how this is like mathematically rigorous, and one that appealed to like companies. And so for this one, we wrote differential privacy is a novel mathematical technique to preserve privacy, which is used by companies like Apple and Uber. And I'm sorry, like in advance for this group, you are not in those two. I'm very sorry. 5, DP reduces user risk, and this kind of addressed what are the risks that are mitigated through the use of differential privacy. And so this one says like a differential privacy protects a user's identity and the specifics of their data, meaning individuals incur almost no risk by joining the data set. And then our sixth one is actually a direct quote from the Dworko 8 paper, and this is a technical description that is closer to what we see in our papers and talks, but is maybe not quite what you want to put on a billboard, but it is very precise. And so this one says, differential privacy ensures the removal or addition of a single database item does not substantially affect the outcome of any analysis. It follows that no risk is incurred by joining the database, providing a mathematically rigorous means of coping with the fact that distributional information may be disclosive. Okay, and so these are our 6 differential privacy descriptions. And so then we return to our original vignettes, and they're the same as before, but then we added this extra paragraph at the end. To reduce intrusion into personal privacy, your friend says they will use a technique that is called differential privacy. And then we inserted one of the 6 DP descriptions on the previous slides here. And we also had a kind of a no privacy condition where we just didn't give additional information. And we had the same thing on our second vignette, how we wrote to reduce the intrusion into personal privacy, your doctor says they will use a technique that is called differential privacy. And again, we had 7 conditions, our first 6 descriptions, and then a kind of a no privacy case. And our survey now asks these questions. And so we first asked, would you be willing to share your data? And so here we have not set users' privacy expectations explicitly. We have said, here is a privacy description. Given this, would you be willing to share your data? And then we also asked them, which of these possible information disclosures would you expect to be possible for your data? And it was the same 6 as before. And I should say that we got fresh participants for these 2 surveys, and so there is no cross contamination from the first one into this one. And so to address our research question 3, how do differential privacy descriptions affect privacy expectations? We again have a big table. The columns are the possible privacy disclosures, and the rows are these different DP descriptions. And the odds ratio this time measures a change in odds of expecting protection against this disclosure compared against a no privacy baseline condition. And so here having an odds ratio above 1 means that you have increased privacy expectations, and our confidence intervals again were at the 95%. Good, and so there's kind of a lot of numbers here. How should you read this? Well, there's a few different ways. First of all, you can look at the columns, and you can ask what things did tend to have increased privacy expectations under most or all of these DP descriptions compared against a no privacy condition. And we see that in general, people do tend to have increased expectations of protections against disclosures to the data analyst and graphs computed based on their data, and in large part against hacks. We saw people didn't really tend to have increased expectations privacy protections against kind of like organizations and the like law enforcement. And we saw that like, in some cases, they did think they had like increased privacy protection against like third-party sharing. And so then we can also look at these rows. We can ask which of these DP descriptions tended to make users feel as if they had more privacy protections against these type of like disclosures. And we see talking about the techniques used to achieve DP did result in a lot of increased privacy expectations. Similarly, talking about the risks that are mitigated through the use of DP also tend to increase privacy expectations in a lot of cases. We also saw some pretty good performance as we're talking about kind of what it enables, and it's a technical definition. And I guess talking about risks makes you think you have increased protection against kind of law enforcement. And so we have these things, and so this tells us what privacy protections do users think they're going to have under various descriptions of differential privacy. And we would like to not just make them think they have more privacy protections, but rather we'd like them to have correct expectations for their privacy protections. And so to kind of talk about correctness, we have to delve into this local versus central question. I have this slide for kind of other talks I've given. Again, I'm guessing in this audience I don't have to say much about it, but the key point is that if we're talking about central DP, users are going to provide their exact data to a trusted data curator who will then promise they're only going to publish things, graphs, charts, statistics, models, using a DP algorithms. And this is central because there exists a single centralized data set containing everyone's data. And this is because there exists a data set, it is vulnerable to things like hacks, law enforcement subpoenas, data sharing agreements, and so on. And of course, we know, despite the fact that it's more vulnerable, there is an increased privacy, or there is an increased accuracy of the analysis for the same fixed sample size and privacy parameter. And so here, this notion of trust is really key because you have to trust curator, for example, to have very strong security protocols to make sure hacks can't happen. You have to make sure that you trust who they agree to share data with, and you have to trust. I mean, I guess this is political question in the news in the last few years, but you have to trust they will do things you agree with. On the other hand, in the local model, of course, users are going to add noise to their data before they even provide it to the data curator. And so in this case, a kind of analyst never sees exact data. They only see a noisy signal about your data. And so because there is no single database containing everyone's data, that database is not vulnerable to hacks, subpoenas, sharing agreements, because there doesn't exist a database. There's of course a much more kind of nuanced conversation to be had that we're purposely not having here about whether noisy signals about your data constitute your data, and we're gonna not address that at all in this talk. But of course, that is a very important detail. And so this gives us ground truth vulnerabilities in the local versus a central model. And as I mentioned before, the one thing differential privacy unequivocally protects against it is your kind of personal information leakage in things computed in the aggregate based on your data, graphs, charts, models, etc. And so in both models, you are not going to have vulnerability against this disclosure. But for kind of everything else, that a disclosure is possible in the central model, but is not possible in the local model. And again, there there deserves to be a like, tremendous like, asterisk here claiming this is ground truth is of course it depends on the implementation. It depends on whether like, whether the like, curator has strong like, security protocols in place. It depends on the epsilon used. This point about the analyst, we know that kind of like, Uber started using DP in the central model because it didn't quite trust its analysts to see the raw data. And so in fact, in that case, there was like, protection against the analysts in the like central model. And so this kind of like, asterisk says for a like typical implementation, but certainly the like quote unquote ground truth will depend a whole lot on the details. We're gonna kind of like use this as our ground truth for now and agree this needs more work to kind of address all of those in a futures study. And so then we can look at users like correctness of like expectations compared against these like differing like ground truths. And so we have here in the local model all 7 different like DP descriptions, including our baseline. And we've kind of like aggregated across like all of these expectations across these different like disclosure possibilities compared against the ground truth in the local model versus in the central model. And for each one, we've asked what fraction of their beliefs were correct. And so because these were like true or false questions, we see the kind of like in the central model, they were doing like about as well as like random guessing. So that's not particularly inspiring. It's certainly not inspiring in the local model. They're doing like much, much worse than in kind of like random guessing. And so this definitely tells us future work is needed to kind of delve into these like nuances of the differences of like descriptions. To kind of capture like implementation details. And this is like especially challenging because in our current DP descriptions used in practice, we see things like DP is a gold standard. Okay, so are they talking about the local model or about the like central model? And so these things, a lot of the ways in which DP is like described doesn't distinguish between these two models. And so it's kind of like, no surprise, users do not have like correct expectations because we're not even trying to like distinguish between these two models. And then for the final research question, we want to know how did these like DP descriptions affect sharing of data? And we have like the same thing again, odds ratio compared against like a no privacy baseline condition, and we actually didn't see like a significant difference across any of them. And so this is kind of interesting because it tells us DP descriptions have like no significant effect, although we did see highly significant findings that they were more likely to share in the salary scenario than they were in this like healthcare scenario. And so this tells us the context of the data and the content of the data as well certainly matter in terms of users' willingness to share data, and the type of data that are deemed more private and more sensitive are naturally going to be less likely to be shared. And so just to kind of like return how we have this like pipeline, we've kind of like addressed these two questions separately, and we'd like to be able to say something about them together. How does my DP description push through this pipeline impact willingness to share data? And effectively, these two things kind of interplay. And so if you are concerned about the kind of things that are addressed by the DP description, then you're more likely to share data. And so in this picture, here's kind of like, 3 different examples where you may have like, no increased sharing, partial increased sharing, and like, a large amount of kind of like increased sharing, where in these examples, users may have concerns about some of these possible information disclosures here. And we also now know, because of this last survey, how we can map from the description into what kind of like information disclosure possibilities users feel are sufficiently addressed by this like a description. And if there's no overlap between the user's concerns and the privacy protections addressed through this DP, the description, then we like shouldn't expect to see very much increased sharing. On the other hand, if there's partial overlap, then we should see some increased sharing. And if there's like a large overlap, then we should see a lot more increased sharing. And so this is the kind of like pipeline one should be thinking about. And we did see that like different users had different concerns. And so it isn't one single like, universal concern, but rather you may want to like, tailor the privacy description to the user, or perhaps offer like, multiple DP descriptions that are going to address multiple of these possible concerns. And so just to kind of like wrap up, we see that in general, users do care about the type of like information disclosures DP like protects against, and their willingness to share data is certainly related to the risk of most information disclosures. And again, we saw some kind of like differences there. And we also saw that like DP descriptions do have a significant impact on users' privacy expectations, but kind of surprisingly, not necessarily on their willingness to share data. And we think it may be because of this like an overlap question. Maybe the DP descriptions were not addressing what users are truly concerned about. And in general, we certainly need more work to like describe like details of these like DP implementations, local versus central, how do we address epsilon and things like this. And I'm very happy to have any questions now. I'll make a very small note about our title. This actually came from a user response, is we asked them if they would be willing to share data, why or why not, and they said no, I need a better description, and this just felt like a perfect title for this work.
Thank you very much. Do we have questions?
Everyone is sad that it isn't like an algorithms paper.
So one question that I have, which is a super hard one, is how do we, there's different variants of differential privacy now. We have, epsilon delta, we have Renyi DP, concentrated DP, Gaussian DP. Do you think there's any hope of explaining these variants to people?
I do think there is hope. And like in a sense, actually this survey gave me hope. I was kind of worried people wouldn't even have a response to these different like, DP like descriptions. And the fact that they did gives me hope. I also think we should have realistic expectations about what we can expect lay users to kind of understand. In fact, here, I'll stop sharing. How do I stop sharing? Okay. So I think that we can certainly explain to them, for example, the difference between the local and the central model. Because I think there's very clear, even in kind of like non-technical terms, what are the difference, and so that seems very possible. I think that we can explain to them epsilon to a certain extent. I think that we shouldn't expect them to have nuanced preferences over like epsilon 0.01 versus 0.05. I think it's all going to be the same, but they should certainly have a preference between like epsilon equals 1 versus epsilon equals 10. And I think some work will be needed there to figure out what is the level of granularity people can actually like reason about in terms of their epsilon, and how do you like describe it to them. Because we know people are bad at reasoning about like probabilities in general. They're certainly bad at reasoning about the like worst case bound of the ratio on probabilities as an exponent. And so certainly some work is required there to kind of understand what is the language and what is like reasonable to expect a person to be able to like distinguish between. I have maybe some hope that people can reason about the difference between like, epsilon DP, Renyi concentrated, truncated DP, things like this, because that we can do by kind of explaining what's going on in the delta. Like, is the delta, worst case is the delta, we can release something, but not everything. I do think in doing this, we risk having them hate regular DP, because one, like, a very simple way to kind of like explain, like, epsilon delta DP is I can say there's a very small delta probability, I can like publish your data in the clear. And while that is like true under the definition, that's like not what our typical epsilon delta algorithms do. And so I think that will require more thinking on the technical side. How can we like describe epsilon delta without just being like, I might publish your data, because of course users will not like that. And that's also not like really what we're happening if we have this like, epsilon delta algorithm.
Can I ask one follow-up question to Thomas? So
Yeah.
even to experts, the value of epsilon is not clear, right? Let me quantify that. I have an epsilon of 10. And even, let's say I have a machine learning algorithm which runs for 100 epochs, and this epsilon of 10 is kind of broken into each of the epochs over this 100 epochs, versus I have a algorithm with epsilon of 10 where I'm outputting a single bit with the response is epsilon of 10. These two epsilons mean wildly different things.
Yeah, yeah.
And even to experts, these are not clear how to kind of capture these notions. At least I don't know a clear way of kind of conveying to even experts. The question is, how do we expect to do these things to layman or laywoman?
Yeah, yeah. That is very true. Epsilon is not the only parameter that matters. And so I completely agree with that point, that it's not just about epsilon. It's not just about the like parameter. And I mean, this is also true as we talk about different like, compositions. I can have a kind of like, exact same algorithm, and it can be like, this epsilon or this epsilon, depending on the composition I use. As we move into new advanced techniques on privacy amplification, we're seeing how to get more information out of the same epsilon. And so again, the epsilon is like something, but it's certainly not the end of the story. And I agree, more work needs to be done in figuring out what is the thing that we're actually trying to capture as we talk about epsilon, because really like, as we talk about epsilon, we're probably not going to like explain to them mathematically what the epsilon is, but it might be something like, there is at most a blah % chance of your information being revealed, and that may or may not be tied to the actual epsilon value.
Rachel, I was wondering if, beyond differential privacy, if informing the users about other practices, things like data minimization and model auditing, memorization, so on and so forth, if those may impact the perception of users about the practices of a certain company. And if you maybe split the groups if you split people into two groups and tell one group about DP and another group about the other stuff, which group would feel more, comfortable sharing data, for instance? Just wondering, to theoreticians, DP is the gold standard, right? But maybe when you explain the other things, people would feel better about privacy.
Yeah, that's a really good question. And we focused here just on like DP, but we'll be the first to admit this is not kind of like all-encompassing privacy expectations. It's mostly in the context of like DP, and really like DP is not a kind of like standalone tool, but rather has to be paired with things like data like minimization, compliance with privacy laws, good, like, security in crypto, employee best practices, all of these things is a privacy environment, and DP is one piece of the puzzle, but it's like certainly not where the story ends. I think it'd be very interesting to kind of explore how users feel about DP compared to the other pieces of the privacy puzzle, and then also how they feel about the puzzle as a whole. Could we tell them that we're doing data minimization and we're doing DP on top of it? Are these things like additive, supermodular, submodular, as you add kind of more and more privacy protections into the mix?